Welcome to Lesson 3 of CTI 141, where we focus on locking down data by exploring secure storage systems and access control in the cloud. As more businesses transition to cloud-based infrastructure, the need to secure the data being stored, whether it's customer records, proprietary assets, or internal documents, has become not just a recommendation, but a requirement. In this lesson, you'll gain a solid understanding of how different types of cloud storage work, how encryption plays a vital role in protecting that data, and how access should be governed through tools like IAM. We'll also dive into real-world examples of what happens when storage is misconfigured or left unprotected, reinforcing that security is a daily, intentional practice, not something that can be set once and forgotten. By the end, you should be able to identify vulnerabilities and apply best practices that minimize risk and uphold data integrity in any cloud environment. Before we dive into the technical side, it's important to take stock of your current understanding. This slide invites you to reflect on what you know, or think you know, about securing cloud storage. Can you describe what encryption at rest is? Have you heard of IAM roles? Do you understand why segmentation might be necessary in cloud environments? Write down any best practices you're already familiar with. Things like password policies, using firewalls, or data backups. Then jot down anything you feel unsure about or want to explore more deeply, such as securing APIs or lifecycle automation. This activity isn't just for tracking knowledge. It's to prime your mind to engage more critically with the lesson, and we'll circle back to it later so you can measure how far you've come. Cloud storage is the digital warehouse where modern organizations store and access their data via the internet, using infrastructure managed by third-party providers like Amazon Web Services, Microsoft Azure, or Google Cloud. Instead of purchasing and maintaining physical servers, businesses can store massive amounts of data remotely, benefiting from elastic scalability, geo-redundancy, and flexible pricing models that adjust based on usage. What makes this model powerful is its ability to support global operations, real-time collaboration, and disaster recovery, all without owning any hardware. However, this convenience introduces new security challenges, such as securing access from remote users, protecting data across distributed locations, and ensuring compliance with global data privacy laws. Understanding the structure and capabilities of cloud storage sets the stage for how we'll protect it in the slides to come. To protect cloud storage effectively, you must understand its various forms: object, block, and file storage, because each is designed for different use cases and carries unique security implications. Object storage, like Amazon S3, is optimized for storing unstructured data such as videos, backups, and logs, and it allows metadata to be attached to each object for efficient searching and version control. Block storage, such as AWS EBS or Azure disks, breaks data into chunks or blocks that function like raw hard drives, ideal for high-performance applications like databases and virtual machine storage. File storage, like AWS EFS or Azure Files, mimics traditional file systems with directories and file names, making it suitable for shared network drives and collaborative projects. Each type requires distinct controls and configurations to ensure confidentiality, integrity, and availability, whether that means encrypting individual objects, restricting access to block volumes, or logging file-level activity. Even the most robust cloud storage systems are vulnerable if mismanaged, and understanding common threats is the first step toward mitigation. A top concern is misconfigured permissions, where folders or buckets are accidentally made public or accessible to too many users. Excessive access privileges, when users have more permissions than they need, can open the door for abuse or costly mistakes. Unencrypted data is another ticking time bomb. If intercepted or accessed during a breach, it can be read in plain text, exposing everything from intellectual property to social security numbers. Insider threats, employees or contractors who already have access, round out the list of concerns, especially when activity is not audited or restricted by job role. These risks can result in data loss, legal consequences, and reputational damage. A secure system requires awareness, configuration discipline, and continual monitoring to prevent these avoidable security failures. Encryption is your digital bodyguard. It protects data by converting it into unreadable code, unless the correct key is used to unlock it. In cloud storage, data encryption must happen both at rest and in transit. At-rest encryption ensures that data stored on disks or in storage volumes is unreadable, even if those resources are compromised or stolen. In-transit encryption protects data while it's being transmitted over networks, whether between data centers, user devices, or external APIs, preventing interception or man-in-the-middle attacks. The effectiveness of encryption relies not just on the algorithms used, but on how keys are managed, rotated, and protected. Without strong encryption practices, even a minor breach could result in massive data exposure, making it a non-negotiable requirement in any secure cloud strategy. Each major cloud provider offers specialized tools to help organizations implement and manage encryption policies. Amazon Web Services uses Key Management Service, KMS, allowing admins to create, rotate, disable, and audit cryptographic keys used in services like S3 and EBS. Azure's Key Vault serves a similar role but extends to secrets and certificates as well, providing centralized control over encryption elements. Google Cloud's Cloud KMS offers options for automated key generation or bringing your own encryption keys, BYOK, giving organizations more flexibility and compliance assurance. These tools are vital not just for encryption, but also for enforcing who can access or manage keys, integrating with auditing systems, and ensuring that encryption is applied uniformly across cloud services. Leveraging them correctly means balancing automation with oversight and always knowing who holds the keys to your kingdom. In one infamous case, a cloud storage provider left over 1 million unencrypted patient records exposed due to a misconfigured repository accessible via a public URL. The breach remained undetected for months until discovered by an ethical hacker, exposing deeply personal medical information. This event is a textbook example of how dangerous it is to assume cloud services are secure by default. Without encryption, sensitive data becomes low-hanging fruit for cybercriminals, and misconfigurations can turn simple oversights into catastrophic breaches. The fallout included potential HIPAA violations, public embarrassment, and eroded trust. This example reinforces a golden rule in cloud security. If your data isn't encrypted, you should assume it's exposed. Identity and Access Management, IAM, is one of the most powerful tools in cloud security because it determines who has access to what resources and what they're allowed to do with them. IAM controls are built on users, groups, roles, and policies, and when configured properly, they allow for precise control over every cloud asset. For instance, a developer might have access to upload code but not modify billing settings. IAM supports the principle of least privilege, which means users are granted only the permissions necessary to perform their job and nothing more. This limits the damage if credentials are compromised or if an insider misuses access. Poorly configured IAM is one of the leading causes of cloud breaches, so understanding and using it wisely is essential for every cloud administrator and security analyst alike. Strong IAM management isn't just a matter of creating users and assigning them roles. It's a strategic process that involves ongoing maintenance and awareness. One best practice is using roles instead of hard-coded access keys embedded in code, which can easily be leaked or compromised. Least privilege access should be applied consistently, so every user or system component is only able to do exactly what's required. Enforcing multi-factor authentication, MFA, adds a second layer of defense against compromised credentials. And crucially, all IAM changes, whether it's adding new users, changing roles, or modifying policies, should be logged and monitored with alerts, enabling immediate investigation of suspicious behavior. These practices combine to create a dynamic and adaptive security model that helps close doors before threats can walk through them. IAM policies are essentially the rule books that cloud environments follow when deciding whether to allow or deny specific actions by a user, application, or service. Written in JSON format, these policies can be extremely detailed, specifying allowed actions like S3 get object, resources such as a specific bucket, and even conditions, like only allowing access from a certain IP range. For example, a policy might grant read-only access to a group of interns working on a data project, ensuring they can't accidentally or intentionally delete files. This level of control supports both security and operational efficiency, but policies must be crafted and tested carefully. A poorly written policy can either block critical functionality or open up more access than intended. Using policy simulators and regular audits ensures that permissions remain aligned with evolving user roles and security needs. Segmentation in cloud storage is like putting your valuable data into separate locked rooms instead of tossing everything into one giant vault. This strategy helps organizations limit exposure by separating data by department, sensitivity, or access level. For instance, HR files containing personal information can be placed in a different segment from marketing data used for public campaigns. This approach doesn't just reduce the blast radius in the event of a breach, it also simplifies auditing and compliance. When data access is restricted and well documented, it becomes easier to trace who accessed what and when. Segmenting also promotes operational clarity, ensuring that teams can't accidentally alter or delete data they shouldn't have access to. It's an essential step in building a layered security model that supports both day-to-day efficiency and long-term risk management. While it's common to think of hackers and cybercriminals as the biggest threats to data security, insiders often pose an even greater risk because they already have access. These threats can be malicious, like a disgruntled employee selling company data, or accidental, such as someone uploading confidential files to a personal cloud account without realizing the implications. Mitigating insider threats requires a combination of technology and policy. Audit logs that track every access attempt, restricted permissions for high-risk actions like deleting storage buckets, and frequent key rotation to minimize the window of exposure if a credential is leaked. Organizations must also foster a culture of security awareness, where employees are trained to recognize the value of data and the risks of mishandling it. Ultimately, trust is important, but blind trust without verification is dangerous. Unauthorized access occurs when someone gains entry to cloud storage without proper permissions, and this can happen through various means: weak passwords, open access settings, leaked keys, or poorly secured APIs. For example, a cloud storage bucket set to public might expose sensitive documents to anyone with a link, and attackers can use automated tools to scan for such vulnerabilities. Similarly, if an API allows unauthenticated access to upload or delete data, it becomes a golden opportunity for exploitation. Preventing these scenarios requires a multi-pronged approach. Enforce multi-factor authentication, rotate credentials regularly, lock down public settings unless absolutely necessary, and use secure tokens or private endpoints for API communication. Regular reviews of access policies and real-time monitoring can further reduce the chance that a simple oversight turns into a major incident. In early 2025, Gravy Analytics, a company that collects and sells location data from mobile apps, suffered a major breach when unauthorized individuals accessed sensitive location data stored on AWS. This data included movements around highly secure locations like the White House and the Vatican, raising serious national security and privacy concerns. The breach likely stemmed from poorly secured access controls, underscoring how vital it is to regularly audit and harden cloud storage environments. Gravy Analytics had to report the incident to regulatory authorities and faced both reputational damage and potential legal consequences. This event reminds us that cloud security isn't just about protecting business secrets, it's also about protecting people's lives and privacy. Every organization, regardless of size or industry, must treat storage security as a top priority and never assume that default settings are enough. Monitoring and logging serve as the eyes and ears of your cloud environment, tracking every action, request, and change across your storage systems. Tools like AWS CloudTrail, Azure Monitor, and Google Cloud Audit Logs give administrators real-time insight into who did what, when, and from where. These logs are invaluable for incident response, compliance audits, and forensic investigations after a breach. Without logging, it's nearly impossible to reconstruct events or understand the scope of a compromise. Beyond just storing logs, organizations must analyze them regularly, either manually or through integration with SIEM platforms like Splunk or Microsoft Sentinel. Logs should also be retained for a reasonable period, typically at least 90 days, and stored securely to prevent tampering. The message here is clear. If it's not being monitored, it's not being managed. Real-time alerts act as your early warning system, flagging potentially harmful activity the moment it occurs. Whether it's someone trying to delete a bucket, make a file public, or download massive amounts of data, alerts help teams respond before serious damage is done. These notifications can be integrated into SIEM systems, emailed to administrators, or even piped into Slack channels to ensure rapid awareness. The key is not just setting alerts, but tuning them properly. Too few, and you miss real threats. Too many, and your team may ignore them. High-value operations like permission changes, large data exports, or repeated failed access attempts should trigger immediate action. In an era where breaches can unfold in minutes, having a real-time alerting strategy is essential for containing threats and minimizing impact. A well-written cloud storage policy acts like a constitution for your organization's data. It outlines rules for classification, access, encryption, retention, and monitoring. For example, such a policy might state that all sensitive data must be encrypted at rest using customer-managed keys, or that HR data should be segmented from other business units. The policy should also include backup frequency, audit log retention, key rotation schedules, and incident response procedures. Importantly, policies should reference regulatory requirements such as HIPAA or NIST 853, aligning internal practices with external compliance standards. A storage policy is not a static document. It should be reviewed and updated regularly to reflect changes in business structure, threat landscape, or cloud provider capabilities. It ensures consistency, supports governance, and acts as a guide for decision-making in high-stakes environments. Different cloud providers offer a variety of built-in tools to secure and manage storage effectively, and understanding these features helps you make smarter architectural decisions. For instance, AWS S3 offers versioning, which keeps older versions of files to support rollback in case of accidental changes, and Object Lock to prevent deletion for compliance retention. Azure Blob Storage uses Shared Access Signatures, SAS, to grant time-limited access to specific resources without exposing account keys. Google Cloud leverages IAM and uniform bucket-level access to streamline permission settings across storage objects. All three platforms offer lifecycle management tools, audit logging, encryption options, and granular access controls. By using these native features, you can enforce security without building custom solutions, saving both time and reducing the risk of misconfigurations. Storage lifecycle management refers to automatically moving data between storage tiers, hot, cool, and archive, based on its age or access patterns. This not only helps cut costs by archiving infrequently used data, but also supports compliance with data retention policies. For example, files older than 180 days may be moved to a cold storage tier, while files nearing their expiration date are deleted automatically. Lifecycle rules help reduce manual maintenance, while ensuring that sensitive data is still governed properly throughout its lifespan. By setting clear expiration dates and retention rules, organizations can balance operational efficiency with regulatory requirements. It also helps reduce your cloud bill, eliminate clutter, and streamline storage audits, making it a best practice for any mature cloud environment. As we wrap up this lesson, let's reflect on the most important strategies for securing data in the cloud. Start by choosing the right storage type for your workload, object, block, or file, and follow that up by encrypting all data both at rest and in transit. Access should be governed using strict IAM policies, with roles, MFA, and least privilege principles always in play. Segmentation limits exposure, while monitoring and logging provide visibility. Real-time alerts enhance your ability to respond quickly, and lifecycle management ensures data is stored efficiently and in compliance with regulations. Most importantly, remember that cloud security is shared. Your provider secures the infrastructure, but you're responsible for configuring it securely. Don't rely on defaults. Stay proactive, review policies often, and treat data security as an ongoing, evolving responsibility. Now that you've completed Lesson 3, take a moment to reflect on what you've learned and how it compares to what you wrote down at the beginning of the lesson. Were the best practices you listed earlier reinforced by the material? Did you find that some of the techniques you were already using are in fact aligned with industry standards? Or did you discover better ways to approach cloud storage security? Go back to the list of questions or uncertainties you wrote down before we began. How many of those questions were answered during the lesson? This post-assessment step is more than just a review. It's an opportunity to actively connect what you've just learned to your real-world environment. Think about how you can apply segmentation, IAM policies, encryption, and monitoring in your current or future cloud projects. If any questions still remain, take note of them and seek out further clarification through additional readings, discussions with peers, or reaching out to your instructor. Cybersecurity is an evolving discipline, and your curiosity and engagement are the most important tools you have to keep learning. This wrap-up is the beginning of applying these strategies in practical, meaningful ways. Congratulations on completing Lesson 3, Locking Down the Data, Secure Storage Systems and Access Controls. In this lesson, you learned how to identify and secure different types of cloud storage, apply encryption at rest and in transit, manage IAM policies, mitigate insider threats, and implement segmentation, auditing, and lifecycle management. You also explored real-world breaches that underscore the importance of proper configuration and continuous monitoring. With this knowledge, you're now better prepared to protect cloud-based data systems and apply these practices in academic, professional, or personal environments. Great work! You're one step closer to mastering cloud security.